Dear students, today our topic is queue. In the previous lecture, we discussed about stack. Queue is almost similar to stack, but it's not exactly the same. Queue is an abstract data structure. It is somewhat similar to stacks. So let me write this down. Queue is an abstract data structure. You can say similar, but we need to remember that it's not the same, similar to stacks. If you forgot what a stack is, I would suggest you to go back to my previous video and check that out. But unlike stacks, a queue is open at both of its ends. One end is always used to insert data, and that process is called enqueue, and the other end is used to remove the data, that is called dequeue. So there are two processes involved. The first process is called enqueue. There is another process that is called dequeue, right? Enqueue and dequeue. So what is enqueue? Enqueue is to insertion of data. You can say when we insert data, that is called enqueue. When we remove the data, that is called dequeue. So these are the two things you need to remember. And queue follows first in, first out methodology. This methodology is followed by queue. What do you understand by a first in first out methodology? What do we understand? So if there is a check way or one way driving road, and if there are, let's say, 4 or 5 cars standing in a queue, so that can be compared with this same scenario, right? In other words, in example, we can say the data item sorted first will be accessed first. So this thing has to be remembered. A real world example of queue can be single lane one way road where the vehicle enters first, exits first. More real world examples can be seen as queues at the ticket windows and bus stops. Now let's get into queue representation. Let's get into queue representation. So as we now understand that in queue we access both ends for different reasons, the following diagram that will be given below tries to explain queue representation as data structure. So let me write this down. Okay then, so this is how the queue representation will look like. So as in stacks, a queue can also be implemented using arrays, linked list, pointers and structures. For the sake of simplicity, we shall implement queues using one-dimensional arrays. Okay, so there are some basic operations. What are those basic operations? Let me write that down first, then I will explain. So queue operations may involve initializing or defining the queue, utilizing it, and then completely erasing it from the memory. So here we shall try to understand the basic operations associated with the queues. So what are the basic operations? Let's first talk about enqueue. It adds, or you can say store, an item to the queue. What about dequeue? It actually removes, or you can say access an item from the queue. Okay, so few more functions are required to make the above mentioned queue operation efficient. Those are, let me write that down here. Those are called, the first one is called pick. It gets the element at the front of the queue without removing it. Okay, this is the first one. Let's get into another one. Next up we have is full. It actually checks if the queue is full. This thing checks if the queue is full. Then we have is empty. This checks if the queue is empty. Okay, so in queue we always dequeue or access data pointed by front pointer, and while enqueuing or storing data in the queue we take help of rear pointer. So this thing is important and we need to remember this one. Let me write this down. In queue we always dequeue data pointed by front pointer, and while n uh, q and queuing, or you can say or storing data in the queue we take help of rear pointer. Okay, this thing is important and you need to remember this one. So let's first learn about supportive function of a cue. The first one, it's pick followed by a parenthesis. So this function helps to see the data at the front of the queue. The algorithm of pick function is as follows. So let me write down the algorithm. So let me recap, or let's say the definition once again. This pick function helps us to see the data at the front of the queue, right? At the front of the queue. The algorithm of pick, I'm writing over here. Let me write down the algorithm. I hope you have understood that one. So as you can see, it is returning the front. So this is the algorithm should look like. And implementation of this algorithm using C programming can be written as this one. Let me write it down as an example. Okay, so this is for pick. Next up, what do we have? Next, we need to talk about is full. Let's get into that one. So, as we are using single dimensional array to implement queue, we just check for the rear pointer to reach the maximum size to determine that the queue is full. In case we maintain the queue in a circular linked list, the algorithm will differ. Algorithm of isFull function can be written as the one that I'm writing right now. So let me write down the algorithm here. right? So the algorithm looks like this, and the example, the implementation of this one in C programming can be written as this. First we write down a boolean, that's a boolean function, then we write down is full followed by a parenthesis, and now we are checking if rear is equal to max size minus 1. If this is true, then return true, otherwise or else return false, right? So this is how it should go. What about the next one? Next up we have is empty. Let's get into that one. Function is empty. The algorithm should go like this. We write like begin procedure is empty if front is less than min or front is greater than rear, then return true, else return false, then end if and procedure. Okay, so the algorithm looks like this. So how is it working? The working principle I have already discussed previously. So this is the algorithm that should look like. So if the value of front is less than min or 0, it tells that the queue is not yet initialized, hence empty. So here's the C programming code. C programming code for is empty. So we start off with a bool, that is boolean is empty if front is less than 0 or front is greater than rear, then true should be returned. Return true, else return false, right? So this is how is empty goes. So next let's look into those two important operations, the NQ operation and the DQ operation. Let's get into that one. First up we have NQ operation. Right. So queues maintain two data pointers, front and rear. So therefore its operations are comparatively difficult to implement than of the stacks. So the following steps should be taken to enqueue a data into a queue. So it can be done using 5 steps. What are those 5 steps? We will see that in a while. Let me write those steps one by one. In step 1, we check if the queue is full. This is our step 1. In step 2, we check if the queue is full. If it is full, we produce overflow error and exit. Right. In step 3, if the queue is not full, then we increment the rear pointer to point the next empty space. If queue is not full, increment rear pointer to point the next empty space. This is our step 3. Let's get into step 4. Now we add data element to the queue location where rear is pointing. Okay, then in step 5 we return success. So these are the 5 steps involved. So this can also be shown using a diagram. Let's say let's look at this diagram. So this is how it should look like. So sometimes we also check to see if a queue is initialized or not to handle unforeseen situations. So if I ask you to write down the algorithm for this, will you be able to do that? So I would suggest you to pause this video, let's say for 1 minute, and think about the algorithm. I have told you the steps involved in this one, in NQ operation. Now it's your turn to pause this video and think about the algorithm and the coding. Done? So okay, then let's get into the algorithm now. The algorithm can be written like, if Q is full, then we return overflow. Right. Real would look as real plus 1. Then the last line is end procedure. This is how it should look like. Okay, so this is the algorithm. The algorithm should look like this, right? So if I tell you to implement this same algorithm in C programming, will you be able to do that? I expect you to do that. So let me write that down for you. I'll write down on paper. You try to do it using your programming and in your compiler. If you face any difficulty, please let me know. I will try to help you out. So let's get into the C programming part. We first write integer type int NQ, then int data. If is full, then return 0. Otherwise, rear is equal to rear plus 1. Q of rear is equal to 10. Then 1 should be returned, and then we need to end the procedure, right? So this is how the NQ operation looks like. So next we have the DQ operation, right? So accessing data from the queue is a process of two tasks. Access the data where front is pointing, and then remove the data after the access. The following steps are taken to perform the DQ operation. Till now we talked about NQ operation. Let's get into the DQ operation now. DQ. Right. So unlike the NQ operation, here also 5 steps are involved. In step number 1, I will write that in brief. Step number 1, it checks if the queue is empty. Check what? If the queue is empty. Then what should be the next step? Step number 2, In step number 2, if the queue is empty, produce underflow error and exit. Right, if queue is empty, if it is empty, let me write that down. If queue is empty, then produce underflow error and exit. Step number 3, if the queue is not empty, access the data where front is pointing. So now let's write down step number 3 once again. If the queue is empty, should I write empty? It should be not empty, right? If the queue is not empty, access the data where front is pointing, right? Then go to step number 4. Then we need to increment front pointer to point the next available data element. Next up we have step number 5. We return success. Right, this is how the DQ operation should look like. So if I get into the algorithm part now, the algorithm should look like this. So we start with the procedure DQ, if queue is empty, then we return underflow and if data is equal queue front, then front is equal front plus 1, then we return true and procedure. Right, the algorithm should look like this. If I ask you to implement this algorithm in C programming, I guess and I hope you will be able to do that. Let me write the example here. You try to do it in your compiler. So first we start with integer tq, then we have if is empty, it should look like this, right? Then we return 0. Then integer data is equal to q front, and front should be equal to front plus 1 and return data. So this is how the example should look like. I hope you have understood. Okay, you see here in integer data equals q front. So the front value, right, in this place the data is getting stored and not stored, it's getting dequeued, and after that we are incrementing the value of front, and after that we are returning the data. So this is how the dequeue operation works. If you have any doubt in any of the points, please let me know. I will try to clarify your doubts, and in the next video we will talk about some other topics. Till then, stay safe and goodbye.